When this ship pulls into Miami, it doesn't look real. Nearly 1,200 feet of steel rising out of the water, decks stacked like a high-rise that decided to go on vacation. Add up every passenger and crew member on board, and you're close to 10,000 people. A small floating city moving under its own power across open ocean. From the dock, that number sounds like marketing. It's only once the ship actually leaves port that the scale becomes real. A crowd that size isn't a headline anymore. It's a constant rolling logistics problem running every hour of every day, whether anyone on board notices or not. For the people who bought a ticket, none of that is supposed to matter. They wake up, turn on a faucet, get dressed, and walk toward breakfast without ever wondering how any of it works. They didn't come here to think about engineering. They came for the pools, the shows, the ocean view from a balcony, and the feeling that a vacation this enormous can still feel effortless. That feeling of ease is not an accident. It's the entire design philosophy the ship is built around, and it takes an extraordinary amount of hidden work to pull off. Step below the public decks, and the whole atmosphere changes. Restaurants, lounges, pools, and cabins give way to something that looks less like a resort and more like a full-scale industrial operation wrapped in steel. Crew members move constantly through service corridors that most guests will never even know exist. Narrow hallways built purely to keep carts, supplies, and equipment flowing without ever crossing paths with a guest enjoying their vacation. The real design challenge is crowd control on an almost impossible scale. You cannot let 10,000 people gather in the same handful of spaces at once. The ship would feel suffocating within an hour. So the layout is engineered to quietly pull people apart. Families drift toward zones built specifically around family activities. Sunseekers climb upward, drawn by pools and water slides on the open-top decks. Everyone on board believes they're simply choosing where to spend their afternoon. In reality, the ship has been shaping that choice from the moment they stepped outside their cabin. The central promenade is one of the clearest examples of this design thinking in action. It's one of the first big spaces guests pass through, so it has to feel bright, open, and welcoming. Nothing like the cramped, dimly lit interiors you'd find deep inside older cruise ships. But building a space that tall and that open creates a serious structural problem. The decks stacked above it still need something solid to rest on. That weight doesn't disappear just because the design calls for an open, airy room below. That's where the giant sculptural centerpiece rising through the middle of the promenade comes in. To a guest, it looks like an art installation, something to stop and take a photo beside. To an engineer, it's doing real structural work, helping carry the load from the decks above so the room around it can stay open without compromising the ship's integrity. Passengers see a landmark. The ship is quietly using it to solve a problem most of them will never notice. None of this works without power, and once this ship is out at sea, there's no plugging into a city grid to fall back on. Every watt it uses, it has to generate itself continuously for the entire length of the voyage. Below the guest decks, the engines function like the ship's own private power plant. This vessel can run on liquefied natural gas, ordinary gas, chilled down until it turns into liquid form, which lets it carry far more usable energy in a much smaller space. But storing fuel that cold while sailing through warm, humid tropical air is not a simple task. The fuel tanks aren't just containers sitting in the hull. They're part of a much larger temperature control system, constantly working to keep that fuel stable. The engines convert that fuel into electricity, and from there, power is distributed exactly where it's needed. Some of it goes to the guest-facing side of the ship: lighting, elevators, kitchens, air conditioning, all the systems that make a hotel at sea function normally. The rest goes toward the equipment that actually moves the ship forward. In the control room, balancing those two demands at once, hour after hour, is a constant active job. At the stern, that forward motion comes from Azipods, rotating electric propulsion units mounted beneath the hull. Unlike a traditional fixed propeller, these can rotate and aim their thrust in almost any direction, which is exactly what allows a ship of this size to maneuver into port with a level of precision that seems almost impossible given its scale. From the guest decks, docking looks slow, calm, even lazy. Underneath the waterline, the propulsion system is making constant small corrections, adjusting for wind pushing against the hull, harbor currents nudging the ship offline, all while bringing almost 1,200 feet of steel toward a narrow pier without room for error. Near the bow, additional thrusters help fine-tune the ship's position when it's close to land. A vessel this size doesn't turn like a car, and it certainly doesn't stop like one. Every meter of movement near a harbor has to be planned and corrected in real time. None of this existed by accident. Long before the ship ever touched water in Miami, it was built at a shipyard in Finland, assembled from massive steel blocks joined together section by section. Some of those blocks already contained wiring, piping, and technical systems before they were ever lifted into position. Building a ship this way gives engineers far more control over the process, but it also leaves almost no room for error. Before any of that steel was joined, digital models were used to check that every pipe, cable, air duct, and service route would actually fit together as planned. A serious mistake discovered only after major sections were already welded together could set the entire project back by months. When the hull finally touched water for the first time, the ship was still far from finished. Floating simply meant the main structure could support itself. The real testing came afterward. Before a single paying guest ever stepped aboard, the ship went through sea trials, taken out to open water, pushed under real conditions. Engines worked harder than they ever would on a normal sailing. Teams on the bridge studied exactly how the vessel responded to sudden demands and tight maneuvers. Every bit of smoothness passengers would later feel had to be proven first, out at sea, away from any dock. Sea trials tend to reveal things that never show up. While a ship is still tied up at port, push the engines harder and engineers start noticing details no one could catch at the pier. A section that vibrates slightly more than expected, a sound traveling somewhere it shouldn't. Small issues like that get identified and corrected before the ship ever enters full commercial service. Even after delivery, the work never really stops. This ship now runs on a repeating cycle. Leave Miami, sail for several days, return, and immediately start preparing to do it all again. To every new group of passengers, the voyage feels brand new, personal, unrepeated. To the crew, it's a rhythm that never fully breaks. In the end, the size of this ship is what gets people's attention first, but size was never the hardest problem to solve. The harder challenge was making something this enormous feel completely ordinary the moment a guest steps aboard. It has to sustain its own life at sea, move like a genuine ocean-going vessel, and still deliver a level of comfort and ease that feels no different from checking into a hotel on land. Guests never came aboard to watch any of these systems work. They came because they wanted everything to feel effortless. And from their point of view, it does. The cabin is ready the moment the door opens. Water runs the instant the faucet turns. The ship glides into port without a single motion that reminds anyone just how massive it truly is. When every hidden system is working exactly as intended, the most complicated parts of this entire vessel simply disappear. Guests see the vacation somewhere below deck. The crew keeps the rest of it alive,